Hi everyone, and welcome to this video where we will be using data on manufacturing overhead costs as well as data on three potential cost drivers to estimate the relationship between the activity that we see in those cost drivers and manufacturing overhead. We're going to do this using scatter plots and regression analyses. So let's hop over to Excel. This is pretty straightforward, a lot easier than you might think. So let's take a look. On your screen, you have an Excel file that contains four columns of data. Column A contains our actual overhead costs, while columns B, C, and D have measures of activity in three different cost drivers. And we are going to try to see if there is some type of relationship between the measurable cost driver and the overhead cost, which is little more difficult for us to track in real time. And the reason we're trying to identify cost drivers is because we would like to allocate overhead based on the amount of activity that we see in a cost driver. To make it more concrete, suppose we have a vehicle maker, a car manufacturer, and we're trying to estimate the relationships between utility costs and the production in our factory. So we might identify as a cost driver the amount of time that the machines on the assembly line are running, and that might be our example or our what we're identifying as something that might explain our total utility costs or overhead costs. Maybe cost driver two might be the number of hours that the assembly line employees work, and that might be a good indication of how our utility costs behave. Or maybe we might have something up here that this is maybe the weather. So cost driver three is the weather, and that somehow relates to our utility costs. Maybe we're thinking if it's hot outside, we run the air conditioner, so that increases our costs. Or in the winter, we might run the heater, and that increases our cost. And so that we've identified this potentially as a third cost driver. And again, all we're trying to say is we want to know in real time, based on the amount of machine hours, how many hours the machines are running, or the number of hours that our employees are putting in, or the weather outside. We want to use these factors, which we can track in real time, to predict what our utility costs are going to be, and also to allocate those costs to each vehicle that we make. Because the goal here is to be able to sell our vehicles at a price that captures all of the cost for us to make that vehicle. And if we do that, we can sell the vehicles at a profit. If we can't accurately track our overhead costs and say that each vehicle is costing X amount of dollars in overhead, then we're going to price our vehicle too low and we're going to lose money on this. So the whole goal here is estimating overhead costs in real time. All right, first thing to do here is you always want to visually see if there's a relationship between these variables before you actually get into estimation. So you would go here to Excel and click Insert, and I'm going to click Scatter Plot, and you'll get a blank chart that looks like this. And the reason for that is because I didn't select any data ahead of time, and that's perfectly fine. All that you have to do is right-click on this chart. Excuse me, I'm just trying to drag this up to the top of the window here so that it is near the top of the data. And I want to just make this big enough so that we can see it once we're ready. And it's a little too big there, so let's just drag this up a bit. Okay, so I'm trying to fit it on the screen here so you can see. I'm going to right-click here, and I'm going to click Select Data. And I'm going to add a series, and my series name is going to be Overhead Costs. And my values, my Y values, the thing that I'm predicting is going to be here in column A. So I'm going to select cells A2 through A3013. We have 3012 observations in this data set, and we're going to use all of that data to estimate the relationship. And then my X is going to be cost driver activity, so cost driver activity 1. And it looks like we're good to go. I'll click OK, and then I'll click OK again. And then if we scroll back up to the top, we will see here is our visual of the relationship between cost driver 1 activity as well as the overhead cost here on the y-axis. And I'm going to just label this because I'm going to reuse it. So I'm going to say this is the overhead cost paired with cost driver 1. All right, this is our visual of the relationship between, along the x-axis, cost driver 1 activity, so the amount of time that the machines are running in the factory, and the total utility costs on the y-axis. And what this is saying is the longer the machines run, the more utility costs we have. And that's what you would expect. The machines take electricity, and so the more they run, the more electricity they use, the higher the electricity bill. And you can see it's a pretty strong positive relationship here. In fact, we could, if we wanted to, we could add a what's called a trend line here. And what this does is it shows an estimate of the relationship. And so it looks like we have a pretty strong positive relationship from this line. All right, so we've estimated cost driver 1. Let's use this and let's also estimate cost driver 2. So I'm going to say insert chart, scatter plot. Oops, bear with me here a second. So insert scatter and not there, right? All right, so now we have our graph for cost driver 1. Let's create the graph for cost driver 2. So I'm going to put it down here. I'm going to say insert chart scatter plot. And I don't want this, right? I want to, this is actually putting it all into one, which sometimes might be useful, but it's kind of like fogging things up here. So let's just make this a little bigger. And let's go in here and select data. And I don't want, let's unselect cost driver 1 and cost driver 3. And click OK. Let's see what this looks like. All right, so now we have the cost driver 2 activity. We can see, it's also showing a positive relationship here, but not quite as large or not as strong as the first one. And I'm going to just add a trend line like I did before. The cool thing is, after I estimated this first scatter plot, Excel kind of recognized what I was doing and automatically selected the data for me. So let's copy this, right? And we'll use that same thing, but now we'll go back in, we'll edit this, and we'll turn on cost 3 instead of cost 2, and we'll click OK. And let's see what this looks like. All right, and so now cost driver 3 kind of looks like a big blob in the middle here. And let's add our trend line, and I expect this to be pretty flat, and in fact that's what we get here. So we get a pretty flat line. It doesn't look like there's much of a relationship here between overhead cost and the cost driver here in cost driver 3. We have a positive relationship in cost driver 2, and then an even more stronger positive relationship in cost driver 1. So let's go in and let's actually estimate our regression now. So I'm going to just select this range, and I'm going to say data, and I'm going to hit data analysis. I'm going to pick regression, click OK. I'm going to put this in a new worksheet, and everything else looks pretty good. So let's see what this looks like. All right, and so we have our output for the regression now. And what this is saying, if you think back to, sorry, I'm just making this bigger so we can see. And let's increase the size of this. Okay, what this is saying is that here is an equation for estimating total overhead costs. And the equation is, if you think back to Algebra 1, the equation for a line is y is equal to m times x plus b. Okay, so this is saying overhead cost is equal to this coefficient, so cost driver 1, multiplied by cost driver activity, or cost driver 1 activity. Let's just for the sake of consistency, let's move this, put this here, and then it's saying also to that add this amount. So I'm going to say plus equals this amount multiplied by cost driver 2 activity. And then finally do add to that this amount multiplied by cost driver 3 activity. And then add the intercept, which is 979. So this is our equation for calculating overhead cost. Overhead cost is equal to 89.57930074 multiplied by the amount of cost driver 1 activity, and then do the same thing for cost driver 2, cost driver 3, add the intercept, and that will give you an estimate. So we can actually plug in our estimates here if we want. So if we go back to our original data, we could add some columns here. I'm going to say insert columns, and I want this cell to be my predicted overhead, and I want this to be my error, and you'll see what the error is in a second, and this will be percentage error. Okay, so predicted overhead is going to be equal to this amount, and actually I'm going to hit F4 to make this an absolute reference, multiplied by the amount of activity in cost driver 1, and that doesn't need to be an absolute reference. I'm going to put this in parentheses though, just so we can keep track of the terms. And to this, I am going to add cost driver 2's estimate multiplied, and let's remember to hit F4, multiplied by cost driver 2 activity, and then we'll say take this and add the number for cost driver 3, make that an absolute reference at F4, multiplied by cost driver 3 activity, and finally add to all of that your intercept, which is 979, and we'll make that an absolute reference. Okay, so now we have a predicted overhead for this amount, and we're also going to calculate how far off are we. So we're going to say take this actual overhead cost, compare it to our predicted, and let's see how far off we are. And if we divide that by the actual, we will see we have about an 8% error there. All right, so you know, it's 92% correct. So let's make this a percentage term. So we're off by 8.04%. Let's make sure that we have all of this correct. So we're taking the cost driver lab. Oh, actually, we do not. So we're not doing, this term is not correct. So this should actually be the cost driver 1 coefficient. So I had a mistake there in the formula, and so now this is more reasonable. We're not off by 8%, we're off by less than 1%. Okay, so we predicted 14,936, and we were off by $130 from 15,066, which is 0.86% error. If we want to, we can copy this all the way down, and we could see we have similar amounts of errors throughout, relatively small. The interesting thing about estimating regression lines is that if you add up all the errors, you should get 0. And let's see, and that, in fact, that's what we get. So the way regression is estimated is it draws this line directly through the middle of the data, and it puts an equal amount of data above the line and below the line. And so the errors above the line are positive and the errors below the line are negative, and when you add positives and negatives together and they're equal in size, you end up with a 0. So it looks like if we go back to our regression estimates again, it looks like there is a strong positive relationship between cost driver 1 and overhead, a positive relationship for cost driver 2, and not much of a relationship for cost driver 3. We see the p-values. These indicate statistical significance, whether or not these are reliable estimates. P-values that are smaller are better. So 5% or less is usually the rule of thumb. We have that for the intercept. This is a very small number. This is scientific notation. We have effectively 0 for cost drivers 1 and 2, but cost driver 3, this is not statistically significant. It's about 31%. Again, we're looking for something smaller than 5%. And so this would say cost driver 3 is not a very good predictor of overhead cost. If we were to actually use this in our operations, we might exclude this from our estimate. But otherwise, we have a pretty good setup here for estimating overhead costs. All right, well, in this video, we learned how to use regression analyses to estimate the relationship between overhead cost and cost drivers. Hopefully you learned something here. Thank you very much for watching, and I'll talk to you soon. Take care.